Hi everyone. So welcome to the day 3 of SQL fundamentals. So as I have mentioned in the previous class, right, today we'll be talking about data types. Before we deep dive into today's class, let us quickly go back and talk about what we discussed yesterday. So yesterday we talked about data definition language, create, alter, drop, and we also learned how to create a table, right? So we discussed that we'll be talking more about data types today. So I'll take you to a website, the Microsoft website, which talks about different data types in SQL Server. So before we go and deep dive into what are the different data types and all, right? So the first thing which I want all of you to understand is like data types is required when you wanted to store a data, right? Like we use data type create table test id as int, right? So here when when you say int, you are telling the system that in the id column you are going to store integer values, right? So this is where a data type comes into picture. Like so how you would define a data type? You understand what types of data you are going to store, and you can categorize that into different like strings, numeric, dates, binary values like images and things like that, or maybe xml. So you can store anything into database, right? So you divide that into separate category. Maybe you might be storing decimals, then you may have a specific precision and all these things. So you got to like choose the right data type based on what you wanted to store. So today what we are going to talk a little more detailed about how do you choose a right data type and what are the major data types we have, right? And people generally misuse the data type, just generalize, okay? Or if it is a string, I'll use varchar, or if it is a number, I'll use int. Then why do we have other data types, right? In today's class, we'll talk about different types of data types and how data types are storing data, which is the right data type which you can use for a couple of use cases. So I'll take you to the website as we discussed. As it says, right, we have different categories: exact number, approximate numbers, date, character string, Unicode string, binary. So exact numbers are nothing but whole numbers. So we have a bit. So I don't go deep into this. Like bit is like if you wanted to store 1 or 0, you'll use bit. And if you wanted to store whole numbers, you will be using like tiny int, small int, big int, and int. So we know that okay, we have int to store number, right? Why do we have these different data types? So let us go in. So this table is something which you all can memorize, which help you to understand some basics about it, right? You can see the smallest one, tiny int. So SQL says that okay, if you are storing something in tiny int, you can store any value between 0 to 255, right? So that is what's tiny int, and small int is like 32,768. You can store a negative and positive values there, and int is again bigger, and big it is like a very big number which you can see, right? So what you have to understand, like the storage, right? You have heard about bytes, right? So in 1 byte, when you convert a number into a byte, the maximum value you can store in 1 byte is 255. That is how the tiny int define that they can maximum store the number 255, and 2 byte is to this 32,767. So so what you have to do here, right? Like when you are going to store an integer or a number value in your column, so you got to understand what am I going to store here. So I'll take a very simplest example, right? The one common mistake I have seen in most of the databases are like you have to store an age. We all know that age is not going to be like more than 150 for sure, right? So everyone by default give int, because we all learn okay, if it is not a decimal point, you got to go int. But when you look at this table, right, you can definitely say that int is not the right data type which you can use to store age, right? Because you only have values less than 150 for sure at this point. So you only need tiny int. Okay, you can still say that, okay, int and tiny int are going to store the numbers, right? Why we have to really consider about like using tiny int above int. So you look at this value, right? It's 1 byte, it is 4 byte. Just to store a value that can be accommodated in 1 byte, you are consuming 4 byte every time. And in case of int and all, whatever this memory allocation it is there, right? That's going to use the entire allocation. So just to store a 1 byte value, you are consuming 4 byte. Think about a table which is having millions of records, right? You are every row you have, you are wasting 3 bytes of data, and that eventually increase the size of your table, right? So higher the size of your table, slower your query should be. This small action of not paying attention to the right data type even bring you into the most complex performance issues in later on. So being a good database developer, I want all of you to think about choosing the right data type when you create when you create a table and a columns data types. I want you to think and precisely choose the right data type. So today I'm not going to cover super detail about everything, but I just wanted to like bring couple of examples like age. I hope you understood like why tiny int plays a key role in using age and why that is important. Like that, I also wanted to talk about char, varchar, and varchar and things like that. Okay, so hope you're clear about integer. So bit we discuss decimal is to store decimal values thing, and money is to store money, and so all these are like you have decimal points and things like that, right? Money is kind of rounded into 2 digits, and approximate numbers are float and real. You already know that, you might know, because which you can store with multiple values after decimal. You can probably use float, but I would always recommend to use decimal with number of columns which are number of values which you wanted to show after decimal, so that like you always have the control over the value how long it will be. And date, we have date data type that store only date, and time that store only time, and date time 2 and date time can be used to store date and time together, like today's date and current time, right? And now let us talk about my favorite area, char and varchar. So if it is a string value which you are going to store, right? When I say string, it is not just string, it can also store numbers. So char and varchar can be used to store string values. So one common question, right? Okay, why do you need two data types, right? Every time I want all of you to think through is like, if you are going to see a two data types fulfilling same requirement, right? Then there is something which you are missing in it, because nobody is going to create duplicate data type for no reason. And if you think that an organization like Microsoft is making that mistake for years, then you are probably wrong. So now what is char, what is varchar, right? Char is a fixed length storage mechanism, and varchar is a um, like variable length mechanism. So how that is different, right? So first point which I wanted to make here is like, if it is char or varchar, you are going to store any type of values, like alphanumerical values can be stored in char and as well as in varchar, so there is no changes. Okay, so now let us take this example, right? I'm setting a number char of 10 and varchar of 10. So how this differ, right? We mentioned like char is fixed length and varchar is variable length. So what happens behind the scene when you set a char of 10 as a column name and you stored a value called Samit, and here also you store the value called Samit. So where this differ, like you have to think about performance and storage at the same point. So this impact when you read the data. So let us learn how SQL read the data here, right? So SQL reads every byte. So like 1 byte, like S will have a binary format value, so it will keep converting and read that. Okay, so now you have char of 10, right? So what SQL is understanding? Okay, I have char with 10 length, so I wanted to read 10 cells. So 1 2 2 3 4 5 6 7 8 9 10. So basically SQL, every time when you set something called char of 10, however you stored one character, two character, three character, SQL is going to read a 10 bytes, right? So now let us come to varchar, right? So how varchar is different here. So varchar understood that, okay, I have a 10 byte, but let my system tell me how many like how many cells or how many bytes I have to read. So varchar, when you say varchar, varchar has an additional mechanism that's called we can call it as length. So length is a 2 byte storage. That's additional overhead for varchar. That will tell the system, okay, length is 6, right? So now when the data type is varchar, first SQL engine will come and check, okay, what is the length? 6. So then it reads 6 characters, right? Then it get the result. So now let us take this example, right? What is the total read or read bytes happened in case of char, right? Char read 10 byte. Varchar is 6 plus it also read length, and this by default 2 byte, so it only read 8 byte. So that is why, like, so you if you take a different example, right? If you are only storing as char number will still be 10, but varchar number is going to be 1 plus 2 3, right? This length is going to change as 1. So this is why char and varchar are being used. If your storing values are fluctuating, like you probably general example is like name, address, and things like that, they don't have a fixed length. But instead of that, you are storing something similar to phone number, that's always 10 digit, right? And if you think like do I use int or big int for phone number, if anybody is thinking that way, that's technically wrong, because numeric values are generally used if you are going to use a number which is calculating and all. So the best way to set a 10 digit phone number and all are is using char of 10. However, we are not storing any string. It is good practice because that is how you can set the length correctly, right? So when that string value is variable, you can use varchar. So now I'll conclude this video just by talking about nchar and nvarchar, right? So so how nvarchar and varchar are different, right? So I said one point to you all that char store read 10 bytes because char allocates 1 byte per character, and nvarchar 2 byte per character. So what is the purpose of nvarchar, right? Because you have char and you can store it. Think about, right, like how actually system works. Everything is binary. You don't have anything beyond binary here, right? So when I write this value, right, if I have this value of so I'll just like select char of 56, right? This is not your character, this is a char function in SQL. So I run it, it is 56 is representing the number 8. Maybe if I give 65, right, it can represents a. So what actually happens, right, when you write print a character, store a character a, so it convert that into a ASCII value, that is 65, and this 65 will be converted into binary. That binary value will be stored. So we have already learned that one byte can maximum store only values up to 255, right? So you see like 65 is a and 66 would be another character. You can test that, right? So one byte can only store the value up to 255. But you know that you have special characters, you have English, small letter, capital letters, all these things, and you also have other languages, right? How do you like accommodate all these in 255? And you cannot have duplicate, right? 65 is capital A and 65 have to be continue to be capital A, right? So here were like our nvarchar or and char come into picture, right? It allocate 2 bytes per character. So that means like your storage of 255 change into like how much value you can store in uh, small int, right? So that is the that I'll show you that, yeah. So now your scope changed to this number, right? So you have plenty of characters can be accommodated. So that said, like what you have to understand here is like you have to use nchar or nvarchar. Char same, char and varchar does the same way how we have discussed previously. But when you use this Unicode character, we call it like n, right? Nchar or nvarchar. The purpose is driven when like you have a string value that is cannot be stored in 1 byte. Like its ASCII value should be more than 255. That is what I would say in a simplest way. So people might be like, maybe by default when you load a data to a database, it might come to nvarchar. That is very common. But what you have to understand is like nvarchar of 10, right, or nchar of 10, you are actually reading 20 bytes. So now you know the answer, right? When there is more read, it takes more time. When there is more like more bytes to be write or read, your performance will be slow and you are consuming additional storage. Being a like good developer and somebody who is very good at design, you have to look at every data type, understand its purpose, and you have to use the exact right data type. When you use the right data type, there are two purposes being fulfilled. One is making sure that like storage is optimized. Second thing, you are indirectly setting a constraint. Like when you set char of 10, you will not be able to store a string which is more than 10 digit, right? So that kind of constraints are also being set. And so varchar of 100, so you cannot store anything beyond 100, right? But less than 100 it will be like variable. So I know like we took a lot of time today, so I'll conclude this video. So we were talking about data type. I hope like which data type you have to use in all the cases. So in the video description, I would probably try to share the Microsoft site link which talks about all these data type, and my understand these data types before designing a table going forward. So thank you for your time. Thanks for watching the video. We'll see you in the next video. Thank you.